So remember, slope of a curve is the two guys that we've been talking about, Leibniz or Newton. Okay, and they both were working on finding tangents. Tangents that skim across a curve and touch it in just one point. Today we want to focus on tangents that are perfectly horizontal. Okay, perfectly horizontal. That means that they are just going straight across your graph. They don't have any slope to them at all. So that's what we're going to focus on today. Okay, so let's take, for example, we kind of looked at this on Friday, an equation of a parabola. So x squared plus 2 is a parabola shape. And we know that the slope on a parabola changes at every point that you're at. Okay, the slope of a parabola changes everywhere you go. So go ahead and put a point on the vertex of the parabola. And then put a couple points kind of symmetrically on either side of the parabola, maybe like that. Kind of equally distant. And then go ahead and in your table, we'll fill in -2, -1, 0, 1, and 2. So we'll do a nice symmetry to this. Okay, each of these points has a different slope because each of these points is at a different spot on the curve. And now we know from Newton and Leibniz how to calculate that exact slope of what it is. But for today, we're just going to estimate. Okay, so let's look at this point -2, which is right here. And then we have -1, and then 0, and then 1 and 2. Okay, let's just estimate what kind of slope it has. And when I say estimate, just tell me if it's like positive or negative or what kind of slope you would estimate. Okay, so Noah, what about -2? What would you estimate that slope to be? Okay, it's going to be a negative slope. So we're going to just go ahead and put a minus sign right here just to show that it is a negative slope. We know that we could figure it out exactly using Newton and Leibniz. In fact, it is -4 exactly when you figure it out. But for today, we're just going to estimate. Okay, Leo, how about at -1? What would you estimate the slope is? Positive or negative or what? It's also going to be negative. So let's put a negative sign here. In fact, on our curve, we could be making little baby tangent lines on here to kind of show that we've got that. Okay, Sydney, how about at 0?
0.
Okay, the line looks like this. And yeah, that has a perfect 0 slope because it's perfectly flat. It's perfectly horizontal. It doesn't go up or down at that spot. It has perfect 0 slope. Okay, Kira, how about at 1? Okay, back to positive again for sure. Like it's starting to turn the corner now and we have a positive slope. And then Nate, how about for 2? Positive. Yeah, even more positive than it was before, but it's still definitely going up. Okay, so a horizontal tangent is happening right here. Okay, a horizontal tangent, and I'm going to color code it the same. That is called a horizontal tangent. So -1 and -2 had negative tangent lines because they had negative slopes. And +1 and +2 had positive tangent lines because they had positive slopes. But at 0, we happen to have a horizontal tangent line because it's the only spot on the whole curve where there is a 0 slope. All right, so that's the definition of a horizontal tangent. That's our next slide. A horizontal tangent is a place where the slope of the curve is 0. Now in a parabola, that only happens one time. But in a curve like what I've drawn now, this is a cubic curve, it happens twice. We have a horizontal tangent in 2 places. One of them we call the maximum horizontal tangent, and one of them we call the minimum, because one is the higher, one is on a peak, and one is on a valley. So this is called the max horizontal tangent, and this is called the minimum horizontal tangent. max or min or maximum or minimum, we abbreviate. So some functions have only one. Other functions have multiple. Can you think of any function that you know of that would have multiple horizontal tangents? Like this is a cubic, so it's gonna only have like one and then another that only has two. Is there one that you can think of that has more than that? Sure, for sure, totally, a sine wave, okay? If you think about a sine wave that just goes up and down and up and down and up and down and up and down, every time it changes direction, it's got another horizontal tangent because the slope keeps changing and changing and changing and changing. Huh? The one I've drawn, this one, is a cubic function, so it has two. A parabola function only has one. The higher up you go, the more it's going to have, okay? All right, good. Good thinking on that, Noah. Okay, so here's the next question. So does this parabola have any horizontal tangents? Does y equals 5 minus 3x minus x squared have any? Okay, well, we can picture a parabola in our head, and sure, it's going to have some. And now our question is, can we find it? Can we find where this would have a horizontal tangent? So first step, find the slope. And finding the slope is finding the derivative. And then our second step, once we've found the slope, is to set the slope, or the derivative, equal to 0. It's almost like a translation game. If you could take the word horizontal tangent and replace each word with what it means, horizontal means 0, and tangent means derivative. And so you have the word 0 derivative. And so that's what we're doing. We're going to find the derivative and we're going to set it equal to 0. So that's our job here. And again, you have multiple ways you can find the derivative. You can do Newton's way or you can do Leibniz's way. You just have to identify which way you're doing by writing the limit down. All right, so if I write limit h approaches 0, you should immediately go, aha, she's doing Newton's way. And the thing is, I don't know the point yet. I don't know that it's going to be the point 1 or the point -3 or the point 5. I don't know the point. So I have to do, what letter do we use to represent any point? Hello? A, okay? Since we don't know what the point is, we have to use the letter A. So we will be doing f of a plus h minus f of a all over h. If you know the point, then you get to use it, 2 plus h, or 7 plus h. But if you don't know the point, then you have to use the arbitrary letter a. And so we're going to put a plus h into this equation. So we'll have 5 minus 3a plus h minus a plus h quantity squared. And then minus, just write the regular a part. So 5 plus 3a plus a squared. All over h. And now we're just going to work it out. And we'll see things cancel, and we'll see things factor, and we'll see things reduce, and it's going to help us figure out what our slope derivative is. So that'll be 5 minus, so I'm going to do all the distributing, okay? 3a minus 3h minus a squared minus 2ah minus h squared. Okay, there's so much. Keep going. Minus 5 plus 3a plus a squared. Now, I know that that is a lot, but after this first step, all this stuff is going to drop out and cancel with each other. So I notice that the first term is a 5, and then somewhere else down the line is another 5 to cancel it out. So we're going to cancel out the 5s here. We're on 44 slide if you want to catch up. And then at the front now we have a 3a, minus 3a. That'll cancel out with another 3a. And what else can we cancel out? Anybody see anything else? I feel like I'm missing something. The a squared, good job. Okay, the a squared I can cancel out. All right, so what I am left with is a minus 3h and a minus 2ah and a minus h squared all over h. So everything I'm left with has an h in it. So that h can factor out and reduce. So when I take the h out of all the terms, I'll have negative 3 plus 2a plus h all over h. So now the h's reduce. So my top h reduces my bottom h. And I'm left with negative 3 plus 2a plus 0, which I plug in. So I get negative 3 plus 2a. Okay, that's, yeah.
Wouldn't it be minus 2?
Yes, thank you. Okay, good catch on that. Okay, like I said earlier, that's going to be like 95% of the work is going to be that part of it. Okay, the part where the first step is finding the slope or derivative. Okay, that's going to be 90 to 90% of the work is doing that. The second step is just to take that and set it equal to 0. And that's not going to take much work at all. So we're going to take negative 3 minus 2a, set it equal to 0, and then solve that equation by doing something to both sides. All right, what should I do first? Negative 3 minus 2a equals 0. How do I solve that? Add 3. So negative 2a equals 3. So a equals negative 3/2. And that is where this parabola has its horizontal tangent. It's the one spot on the parabola that will have the horizontal tangent. So we're doing our math stuff backwards. Before, we were saying, here's the point, find the slope where that point is. Now we're doing it backwards. We're saying, I already know the slope is going to be 0, so find the point that matches that. You understand the difference? One is, here's the point, find the slope. And now it's, here's the slope, work backwards to find the point. And we found our point to be negative 3/2. Okay, so let's do that again. Does the cubic function x cubed minus 6x have any horizontal tangents? Okay, well, yes, it's going to have a couple because it's a cubic, because cubic shapes go up and then down and then back up again. So it's going to have a couple, but let's figure out where they are. And so step 1, find the find the derivative, the slope. So this time, I'm going to do x approaching a. All right, I'll do it that way for you guys this time. So that means I'm going to have f of a minus, I'm going to have f of x minus f of a over x minus a. Okay, that's going to give me f of x, that'll be x cubed minus 6x, parentheses, minus f of a. So that'll be a cubed minus 6a, parentheses, all over x minus a. And now I'm going to put this in order and see what's going to happen. X cubed comes first. A cubed comes second. Minus 6x comes next. And 6a comes last. All over x minus a. Okay, I'm just reminding you, you don't have to do it this way, right? If you like Newton's way better, then do Newton's way. Or if you get stuck on one of the ways, then switch to the other way. You've got multiple ways to do it. Now I noticed that I have a couple common 6s. So let me show you. So I'm going to take 6 out of those, -6, and I'm left with, oh, I forgot to distribute. So I'm left with x minus a. Oops. My other one is still x cubed minus a cubed. So I did have some common stuff with the 6s, but there's nothing common with x cubed and a cubed. We call that the difference of, what do you think? It's not squares. It's the difference of cubes this time. All right, we know what to do with the difference of squares. X minus a, x plus a. We might not know what to do with the difference of cubes. Okay, you can Google. I don't expect you to memorize the difference of cubes. I do expect you to know the difference of squares. But difference of cubes you might not have memorized, so you can Google it. You just type in difference of cubes. So I'll tell you what it comes out to be. It comes out to be, well, we know difference of squares is x minus a, x plus a. Difference of cubes is also x minus a, is what it starts with. But the rest of it is x squared plus ax plus a squared minus 6 and x minus a. All over x minus a. Now this minus 6 part is a separate part of the problem. So I'm going to make this common denominators. So I'm going to take my x minus a, x squared plus a squared plus ax, and put it over its own x minus a. And then I'm going to put minus a limit, and I'm going to do the other one separate. Like it's a whole separate thing. It's got its own, we call that common denominators, right? Common denominator for this guy, common denominator for that guy. Why is it good for me to do that? What do you see that I can do once I've done that? Why is it good to split it up? What do you see about this?
Cancel out.
It does. It cancels out with here. Okay? But what else do you see?
Cancel out.
Cancels out over here too. If I had not done my common denominators and I tried to reduce before, then maybe I wouldn't have reduced right. Because probably what you would have done is usually people take this x minus a, if you can look, and that one, and they just cross those two out. And then they forget about this one over here, and it never gets crossed out like it's supposed to. So that's why it's really better to split this up into a common denominator so that it can get reduced here and it can be used to reduce there. That's the best way to do it. Okay, like I said, this is 90% of the work. So now we're to, what were we left with? Okay, we were left with x squared plus ax plus a squared. That's in parentheses. And then minus 6 is all that I'm left with on the other one. I don't even need limit anymore because it doesn't even have any letters in it. It only has variables. So now I can change all my x's to a's. And I finally ultimately get a squared plus a squared plus a squared minus 6. Or 3a squared minus 6. So that's 90% of the work. And I finally got to 3a squared minus 6. Huh. What do I do with that when I actually finally get it? Okay, I've got all that way. All right, so Nick, what do we finally do now?
Set it equal to 0.
Set it equal to 0, because we're finding the horizontal tangent. And so now we can finally just take that 3a squared minus 6 and just set it equal to 0 and do a very easy math problem because we did all of the hard, heavy lifting already. So we'll add 6 to both sides, and we'll divide by 3. And I'm sitting here at a squared equals 2, and what's my final step in solving?
You square root it.
What do you have to remember to do when you square root something?
Negative or positive.
Okay, there is a negative and a positive. It has to be a plus or minus square root 2. How could you have caught your mistake? Say you forgot the plus or minus. Say you just said rad 2. How could you be thinking about the question and then still maybe have caught your mistake? Okay, because a equals negative 2 means that there's a horizontal tangent at rad 2. How could you think about the question and realize, shoot, I made a mistake. I'm missing something.
You flip that.
No?
If you visualize the graph,
Okay, if you visualize the graph, what?
there's a max and a min.
Okay, so if you visualize a cubic, there have to be 2 places where there's a horizontal tangent. The question is, does it have any horizontal tangents? And if you visualize it, you should see in your mind an up part, a down part, and then an up part. And so the answer you're thinking of is, yes, it has 2 horizontal tangents. It has one right here where it has a 0 slope, but it has a second one. And so if you just go about your answer and you're like, yep, square root 2, I'm done, you've forgotten the whole other one. And so it's so easy to remember, oh, it's plus or minus. Okay, so rad 2, a equals rad 2, that was actually the min. And a equals negative rad 2, that's actually where the max is happening on that cubic. So always go back to visualizing, how many should I be finding? How many does the graph have so that I make sure I don't miss anything? All right, so here we go. To wrap up everything we've done, there are 5 ways that you can be asked. Actually, I'm going to add a 6th. Okay, add a 6th. I just thought of another one. All of these things all mean the same. Slope of a curve, rate of change of a curve, instantaneous rate change of a curve, velocity, instantaneous velocity. Let's add the word derivative. Ooh, I just thought of another one. Goodness, my list is too short. Tangent. They all mean the same thing. They all mean along a curve of any kind, one point has slope. That's different from all the other curves. And there were 2 ways we learned to do it. They are, and both of them start with limit. That's how you know. F of x minus f of a over x minus a. And you will need to know that that is Leibniz's. The other one is f of x plus h minus f of x over h. And you need to know that that is Newton. So you have 7 ways you can be asked the question and 2 ways that you can use to answer it. So for the last thing, if you have the word average, it means something different. If you have the word average, it means you do not have limit in front. It's still f of b minus f of a, but without the limit, it totally changes things. Without the limit, it means on this curve now that we are now looking at 2 different points that are spread apart from each other. Okay, without the limit, it's 2, and we call that, another way we call that is secant. But the biggest thing mathematically is that there's no limit in front of it. The other 7 ways all require that you're working with a limit. When you throw the word average in there, you don't need a limit anymore, and there's 2 points instead of 1. The limit squeezes everything down to where the 2 points are so close together, they're practically the same. So it's the difference in going from 2 points for a secant to 1 point for a tangent. Secant doesn't need limit. The tangent one does need a limit. Okay? So I'm trying to help you with some of the, on the test, some of the like explanation questions you might have to explain. Or something like that, okay, by talking about these things. Okay, any final questions? Okay, so tomorrow will just be a review day. We're going to take a pre-test in class on Canvas, the one that the last year's group did, part of it. And then I won't see you on Wednesday or Thursday. And then Friday we'll take our test. And then you'll have the weekend off with nothing. Okay. Okay, great. Thanks for your hard work this chapter. Well done. And we're out of here. Christine, do you want me to go back to anything? Or I have the recording. What would you prefer? Recording is okay? It'll just take you a couple minutes to watch the very first part. Okay, yeah.
Can we talk like after spelling?